So this is your Siva sir. So welcome to the Student the Brand live class. So today I'm going to discuss about refraction of light. Refraction of okay. So refraction of light we will discuss. Light refraction. Okay. So we hope we are working on. So light refraction. Light refraction we'll discuss. Okay. So light reflection already we discussed, right? So now we will discuss about light refraction. Refraction topics we'll discuss. So refraction, especially refraction. In refraction phenomena, what are the points we are going to discuss? We'll let you know. Is it clear? No, it is clear. So let me know if it is any concern. So if it is not clear. So refraction of light, refraction. So refraction is nothing but when light is passing from one medium to another medium. Light is passing from one medium to another medium. The bending of the light takes place at the interference of the two media. That is called refraction. Okay. So I'm considering here this is a rarer medium and this one is a denser medium. Rarer medium and denser medium. Okay. Light ray is passing from here. So this is incident ray. So this is a normal line. And this will be the refracted ray. Refracted I'm considering. Incident ray. So I am considering here. So incident ray, refracted ray. Okay. So then we can take this is the refracted ray I am taking. Incident ray. Incident ray. So this is the refracted ray. Refracted ray. Refracted ray. If the light is moving from rarer to denser, if the light ray is moving from rarer to denser, so at the interference of the two media, light ray will bend. At the interference, so this is incident ray, refracted ray. If light ray is passing like this, so at the interference of the two media, it bends. At the interference of the two media, it bends. So this type of the bending of the light at the interference of the two media. The bending of the light at the interference of the two media is called refraction of light. The bending of the light at the interference of the two media is called refraction of light. The bending of the light at the interference of the two media is called refraction of light. Okay. So I am considering here. So incident ray, refracted ray, and this interference where the light ray will bend. The light ray will bend. Okay. So I am taking this one. Clear? So the path light changes at the interference of the two media. The path of the light changes at the interference of the two media. So that is called refraction of light. So hi everyone. So let me know if you any concern, any lighting problem or any board if it is not visible, just let me know. So we'll work on it. Okay, so I'm considering here this is a light ray. So light ray is bending. So the interference of the two media, that is called refraction of light. Okay, so when the light is moving from voice is low. Okay, fine. So I will increase. So is it board is clear? If board is clear, let me know if it is clear. Okay, so I'll continue. Yes. So light ray is moving here. So thank you for confirming. Yes, done. So this incident ray, refracted ray. Light ray is bending at the interference of the two media is called a refraction of light. So the phenomena of bending of the light at the interference of the two media is called a refraction of light. Is called refraction of light. Okay. So if light ray is moving from rarer to denser, it bend towards the normal line. So what happens if the light ray moves from a denser medium to rarer medium? What happens if the light ray moves from denser medium to rarer medium? So I'm taking like this. So this is a rarer medium and denser medium. So this is a normal I'm taking. So if the light ray is passing from denser to rarer, so it moves away from the normal line. So it moves away from the normal line. So if what happens? It bends. Very good. So at the interference of the two media, it bends. Okay, so that is a refraction of light. So it moves away from the normal line. Actually, if the light ray is moving from rarer to denser, it moves towards the normal line. Here, if the light ray is moving from denser to rarer, it moves away from the normal line. It moves away from the normal line. So what is the reason behind of it? The reason behind of it is, so because here speed is decreasing, here speed is increasing, here speed is decreasing, here speed is increasing. So that is the reason. So because of that reason only the light ray will bend. Okay, so it will bend towards the normal line, so it bends away from the normal line. So the entire phenomena, so the bending of the light at interference of the two media is called refraction of light. Just note down this point. So then I'll go to the next one. So I hope it is clear to you. The light is moving when it is moving from then the rarer to denser, it bend towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay, so that is about refraction of light. Clear? Now, so we are going to the next one. Now only started, so you are on time, exactly on time. So I'm checking everything right. So that's the reason, nothing else. So you're on time. Okay, done. So next. So light ray is moving from rarer to denser, it bend towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. So the bending of the light. So the change, actually the path of the light changes. The path of the light changes when it is moving from one medium to another medium. The path of the light changes when it is moving from one medium to another medium. So that is called refraction of light. That is called refraction of light. That is called refraction of light. So now you can see. So I hope it is clear. Next, we are going to the next one, refraction. refractive index. Refractive index. So I'm talking about refractive index. Refractive index. Refractive index. So it's a refractive index. So refractive index is nothing but so speed of light in. So n we can denote. So it is under a loss of refraction. So loss of refraction means so if you are taking the light ray, so this is the light ray, incident ray, incident ray. So this refracted ray, incident ray, incident ray, refracted ray. Light ray is bending. So this is rarer to denser, rarer to denser. This is a refracted ray. This is incident ray. This is a rarer medium, rarer medium. So RM I'm taking. So DM. So rarer medium and denser medium. Incident ray, refracted ray. Incident ray, refracted ray. So speed of light is 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. Okay. Okay, done. So come to the point. Refractive index is nothing but so n denote loss of refraction. First we'll discuss. Then I'll go for refractive index. Loss of refraction. Loss of refraction means you can see. So incident ray, refracted ray, normalized. So this is the normal. Okay, so incident ray, refracted ray, normal. 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 All lies in the same plane. So that is the first point. Coming to the second point. So the sign of angle of incident. So here I am taking incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line. All lies in the same plane. Very good. So very good, Shweta. Okay. So next second one is so sine of angle of incidence, sine of angle of incidence by sine of angle of refraction equal to constant. Sine of angle of refraction equal to constant. Okay, so the ratio of sine of angle of incident to sine of angle of refraction equal to constant. That is nothing but n I am considering. That is a refractive index. That is a refractive index n. Refractive index n. So here refractive index, if you take refractive index, speed of light in vacuum by speed of light in medium. So C by V, speed of light in vacuum by speed of light in medium. Okay, so what is your doubt? What is sine? Sine is nothing but sine I here. This is the angle between incident ray and normal line. So this is called angle of incidence. The angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. The angle of refraction. See, whenever the light is incidenting on it, that is called incident ray. The light which is incidenting on the surface is called incident ray. So this is the normal line. The angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. So we are taking this relation because light is moving from one medium to another medium. That is rarer medium to denser medium. So we have to take the relation, that is so ratio of sine of angle of incidence. Sine of angle of incidence. Why we are taking only sine of angle of incidence? So you are taking this a normal line. So this is the incident ray. So here is the angle of incident I am taking. So this is the distance. So what is the sine angle? Opposite side by hypotenuse. So this is the opposite side. This distance depends on this distance, and this incident rate depends on. This is fixed only, right? This is fixed. So with the relation of this distance and this one, we are considering that is angle. The opposite side by hypotenuse. That is the sine. That's why we are taking sine of angle of incident to sine of angle of refraction. Because so based on this only, right? So the refracted angle moves. Okay, how much angle it depends. So how much angle it incident on it, then refract depends on the medium, depends on the refractive index. So the refracted deviate from the normal line. So that's why this ratio of this angle by this angle is called refractive index. That is nothing but sine of angle of incident to sine of angle of refraction equal to constant. So that is nothing but refractive index. So refractive index, if you are taking, so C by V is nothing but speed of light in vacuum by speed of light in medium. So thank you. So speed of light in vacuum by speed of light in medium. So speed of light in vacuum or air. So vacuum or air. C is nothing but speed of light in vacuum or air. Okay. So that is nothing but 3 into 10 power 8 meter per second. So 3 into 10 power 8 meter per second. So C is nothing but what is the value? C is nothing but C equal to 3 into 10 power 8 meter per second. So this is speed of light in vacuum. Speed of light in vacuum or air. So both we can say speed of light in air or vacuum. That is nothing but 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. So that's enough. Now you can consider, so absolute refractive index. Absolute refractive index is nothing but, so ratio of speed of light in vacuum by speed of light in medium. Ratio of speed of light in vacuum by speed of light in medium is called absolute refractive index. Absolute refractive index. Whereas relative refractive index, if you see relative refractive index, relative refractive index, relative refractive index. So speed of light in vacuum, speed of light in medium 1 by speed of light in medium 2. It depends. So speed of light in medium 2 with respect to medium 1. So speed of light in medium 1 with respect to medium 2. Okay. So anything we can take the relation between two mediums. Relation between two mediums, if you consider, that is called a relative refractive index. So if you take only speed of light in vacuum by speed of light in medium, any medium you can take with respect to speed of light in vacuum. If you compare with respect to speed of light in vacuum, with respect to speed of light in vacuum, with respect to speed of light in vacuum, then that is called absolute refractive index. That is called absolute refractive index. If you like this video, so please do like, okay, and subscribe my channel. So then everyone will get to know. So here is a Siva sir is taking class, that to refractive index. Okay, we have to join immediately, otherwise we will miss the class. So not like that. So even after the class also, live class will be uploaded as a normal video. So in the YouTube they can watch. But still, if you like the video, so that will spread to the remaining students also. They will also come and join to the class, right? Okay, done. So refractive index is nothing but speed of light in vacuum by speed of light in medium. So refractive index is nothing but speed of light in vacuum by speed of light in medium. That is called absolute refractive index. Whereas relative refractive index is nothing but, so speed of light in one medium by speed of light in medium 2. So here I am considering. So is it clear? Any doubts? Do you have any doubt? So I'll explain entire chapter. Stay in the live class. Surely, if you have any doubts, we'll work out. So if you have any doubts, so any doubts? No doubts. Okay, done. So n, if you are taking n to 1, so refractive index n2 by n1 I am considering, that is nothing but, so v1 by v2, v1 by v2. Okay, so how we have to represent n2 1, refractive index of medium 2 with respect to medium 1, refractive index of medium 2 with respect to medium 1. So this we can also write like this way. So n2 1, in this way also we can write. So n21 is equal to n2 by n1, that is nothing but v1 by v2. So n is inversely proportional to velocity. So refractive index is inversely proportional to velocity. Okay. So do you have any doubt, children? Students? No doubt. Shall I go to the next question, next concept? Done. So n is inversely proportional to velocity. Refractive index of medium 2 with respect to medium 1, we are considering n2 by n1, that is nothing but v1 by v2. So here like this also we can take. So like this also we can consider, that is nothing but refractive index. Refractive index. Clear? And now, so here we can also write n12, if you are taking 1 by 2, that is nothing but v2 by v1, v2 by v1, v2 by v1. Very, very important concept. So very sensitive concept. Definitely they will ask for one more question, even problems also they will ask. So try to remember this concept, try to work out on this concept. So very important concept. So make sure that you are practicing along with me. So next one we'll go to the next topic. So refractive index sometime until this one completed. So we'll go to the glass lab. I'll explain glass lab now. Laws of refraction already completed. So what are the conditions for no refraction? So when refraction does not takes place, when refraction does not takes place. So if the light ray passes along the normal line, the light ray passes along the normal line. So if it is passing like this, we okay. So refraction does not takes place. Even refractive index of two mediums will be same, then no refraction takes place. So refractive index of two medium will be same, then no refraction takes place. Two cases. So one is light ray passes along the normal line. Second one, so refractive index of two medium will be same. Refractive index of two medium will be same. Okay. So that time no refraction takes place. And next one I will explain about glass lab. I will explain about glass lab. So check once. Glass lab. Glass lab I am taking. Glass lab. So I am considering here this is the glass lab. So incident ray, this is the incident ray. This is the incident ray I am taking. This is a normal line. This is a normal line. So light ray is passing like this. Light ray is passing like this. Okay, this is a refracted ray. And I am considering this again normal. This is emergent ray. The light ray which is passing. This is called emergent ray. This is emergent ray I am taking. So here you can see emergent ray. If you are extending this light ray, so the distance between emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. Lateral shift. Lateral shift. Okay. So incident ray, refracted ray, and emergent ray. Incident ray, refracted ray, and emergent ray. So this initial direction of the incident ray. This is a rarer medium and denser medium. Rarer medium, denser medium. This is a rarer medium, denser medium. So is it clear? Do you have any doubts? Anybody have doubt? Okay, so no problem. So you can check once. So here incident ray, refracted ray, emergent ray, rarer medium and denser medium. Light ray is moving from rarer to denser, bent towards the normal line. If it is moving from denser to rarer, away from the normal line. Away from the normal line. Thank you for confirming. So if it is moving away from the normal line, it moves like this. So the distance between emergent ray and this incident ray, the vertical displacement between emergent ray and incident ray, this is the extended incident ray or initial direction of the incident ray, that is called lateral shift. That is called lateral shift. So this is called lateral shift. And here, when it is moving from rarer to denser, it bend towards the normal line. When it is moving from denser to rarer, it moves away from the normal line. Okay. So one more thing. So based on this refraction, there are a 3 marks question. Lakshya, hi. So hi, welcome to the class. Welcome to the class. So there are 3 points are there. So one is coin placed in the beaker. Coin placed in the beaker. Second one is pencil placed in the beaker. Pencil placed in the beaker. And third one, lemon placed in the lemon. So these 3 questions will come. See, 3 marks question. Definitely 3 marks question will come. So these 3 questions. 3 marks question. Each question 3 marks. Not one question 1 mark. So each question comes for 3 marks. Okay. So when a coin is placed, that question I will explain. Listen carefully. So I am taking one like this beaker. So I am taking one beaker like this. Okay. So shall I rub this one? So is it clear? So please at least respond. Say yes or no. Okay, thank you. Like if you like, you like the content, you can like, and if it is okay, you can share it. So then I will get boosting. Okay, so like that, then automatically I can teach more. So with your support, with your energy, with our what we can say, done. So come to the point. I'm taking this one. So this is the beaker. I'm taking this the beaker. So here coin is placed. So this is the coin. So we can take the coin here. I'm placing the coin at the bottom of the beaker. So bottom of the beaker, I'm placing the coin. I'm standing here. So so I'm only standing. Note line class, sir. Tomorrow is my exam and I can't understand refractor index. I want this type of doubts. I want it. I really want it. So try to ask this type of questions. Refractor index. Yes. Yes. Refractor index, right? Yes, I'll tell. No need to worry about it. Simple definition. See, if they ask refractor index, so the ratio of speed of light in vacuum by speed of light in medium, that is called refractive index. Refractor index is nothing but ratio of speed of light in vacuum by speed of light in medium. Ratio of speed of light in vacuum by speed of light in medium. So here two types of refractive index are there. One is absolute refractive index, another one is relative refractive index. So here I invented, so myself I found three methods. First one is uh, statement method, statement statement method. Second one is representation. Oh, sorry, second one is representation. Second one is sorry for it. What is your name? Note line classes mentioned. What is your name? Representation. So it is better now. I can tell to you only with your name. So instead of going with what is your name? Can you tell your name? You see, I'm explaining for you right now. No, your doubt. So whether you are listening or not, so I can't understand. So if you tell your name, I will call. So if you respond, then I will go to the concept with clear. Okay. Sir, what main will come in exam? My exam, I mean what I should learn. EVA. So you have to learn, see, refractive related to refractive index. Are you CBSE or state or ICSE? Can you confirm? So it depends on the board also. Depends on the board also. See, CBSE will be different. ICSE they will go in depth. Okay, state will go in depth. Okay, in all the categories will be there. CBSE definitely. So related to refractive index, so they will ask about definition first. Definition. Eva, definition they will ask. So the ratio of speed of light in vacuum by speed of light in medium, that is called refractive index. So that point, one point. Second point is, so related problem. I will tell one question for whole chapter. For whole chapter, you have doubt. One question I will tell. So prepare and go. Maybe we can expect that question in exam. So we are guessing. Okay. So I'm guessing this question. Statement method, representation method, formula method. Okay. So I found this method, main question for whole chapter. Main question for whole chapter, yes, this based on this one, 2 marks question. CBSE, if it is CBSE means, so 2 marks question they will ask. So 2 marks question. Damn sure question. So by closing your eyes, you have to prepare and go. So without any doubt, that much important it is. Even in the board exam also. So in the board exam, in the previous, if you observe the previous paper, go and check the papers. Glass lab they asked. Glass lab. So the just now previously I explained, right? A glass lab, refraction through glass lab. That question they asked for 3 marks. 3 marks. That much important it is. So refractor index 2 marks question. Refractor index is 2 marks. Okay. Sir, you are actually working hard. Full support, sir. Um, no words. Thank you so much. So statement method, representation method, formula method. Okay, so I'm going with that. That's enough. So statement method means, so when the light is moving from uh, if they ask in the question, if the light ray is moving from one medium to another medium, so one medium to another medium, one medium to another medium, so refractive index of medium 2 with respect to medium 1, refractive index of medium 2 with respect to medium 1, this is a statement method. So if they give in the statement, so statement point of view, so actually I didn't write the question. Yes, it is there. Mm, yes, these are questions. So these are the questions. These are the questions related to refractive index. So all important questions itself. So I'll tell one question here. The refractive index of alcohol. Yes, this type of questions. The refractive indices of alcohol. Here, this question is very important. You can check this one. So this type of questions they will ask in the exam, in the board exam. So especially if exam is there, so they'll conduct this type of questions. You can check this one. Maybe it's not visible to you, but I will read out. I will read out. Related to coin, lemon, glass slab can come. Yes. So 3 marks, as I said. So I'm going to explain because she asked about refractive index. I'm explaining. So this I will explain. Related to these 3 questions. 3 questions. 1 question compulsory they will ask. 1 question compulsory they will ask. Many times, see, many times this question can expected. So many exams. So even if any exam is there, or a normal test, normal slip test or unit test or midterm or post midterm, or if you are going to any exams, this question can come. This question can come. That is important. That much important. Even coin also. Even coin also. So there is one question is there. There is one question related to coin. So vertical displacement is there. There are so much important it is. So here in these 3 questions, damn surely I am expecting among these 2 questions, 1 question may come for exam. So either normally for board exam I am expecting. See, we can expected questions will come. We will consider only few questions, only few expected questions. Among those expected questions, still we can expect a highly important questions. Like that, I will tell said then. So anyway, I'm explaining the chapter, right? First, let me explain the chapter. Then I will give the full clarity about important questions, where they will ask, how they will ask, what type of questions will come, how to answer, everything. So here refractive index. So let me clarify this one. Refractive index statement method. So refractive index, so if you see when the light is moving from one medium to another medium, if it is moving from one medium to another medium, so the refractive index of medium 2 with respect to medium 1. I'm in Hyderabad right now. Okay, so here if the light ray is moving from medium to medium 1 to 2, so the refractive index of medium 2 with respect to medium 1. See, like this we have to write. So n2 by n1. So whereas velocity if you take v1 by v2, v1 by v2, v1 by v2. Okay, like this we have to write. So this question, so related this statement method, representation. This is only representation. How you have to represent. So refractive index of medium 2 with respect to medium 1. Representation method. So we have to represent. So sometimes they will write like this also. So we have to take n1 by n2. So writing. So we need to understand how to write. Offline class. So you can see near to the in the Hyderabad. So nearby places. So I can take offline classes. Offline classes I can take. Okay, online classes. So wherever I am, so wherever you are, so it is possible. But offline classes, I'm right now in Hyderabad, so nearby. Okay, so you can take the you can ask for offline classes. Offline classes you can ask. So online classes, so anywhere I will be ready. Okay. So what is the location? So location everything. You can, if it is required still more details, if you want, no need to type here. So if you need still more details, you can contact to this number. So this is on this number, WhatsApp is there. Actually, I'll be taking tuitions. I'll be taking classes also. So I have a team members. So all subjects. So not only physics, I'll be remaining subjects also available: maths, chemistry, biology, English, social. So all the subject teachers are there in my team. So mainly I will teach physics from 6 to 12. So JE NEET level physics I'll be teaching. So I'll be going on right now. So I'm fully focusing on grade 10 CBSE physics. Okay. So that's, I already here see, this is my experience, 10 years experience in physics teaching. Okay, so I completed BTech mechanical. That is the reason I am writing. So I already thought. Okay, so still I am working on my one. Okay, so that's, any other doubts? Shall I go to the topic? You see, if you need any queries related to tuitions, related to offline or online classes, you can contact to this number. You can contact to this number. So further details you'll get it. Further details you'll get it. Okay. So refractive index. So statement method, represent method, formula method. So as I said, sine of angle of incident to sine of angle of refraction. Yes or no? Sine of angle of refraction. So before I said no formula, refractive index formula also they will ask related to formula. Related to formula. So sine of angle of incidence to sine of angle of refraction equal to constant. That is equal to the n2, if you are taking n21, that is nothing but v1 by v2. So this is completely related to formula. Based on this one, problems will come. Based on this one, problems will come. Surely problems will come on this concept. Definitely, I am very much confident about it. So this is a refractive index, very small concept, but high weightage. High weightage in the sense high. If you are going to exam hall, so tomorrow exam is there. So you are going to write exam. So light reflection, refraction chapter is there. Compulsory, you have to learn this concept and go. That much important it is, related to glass lab, related to refractive index, because for exams this question definitely they will give either formula, either statement, either definition, anything will give, will we will get from this one, we'll get from this concept. So I hope it is clear to you. Eva, any doubts? Shall I continue the next one? If your doubt is clear means I will continue the next one. So at least say yes or no if you are there, then I will continue. Okay, so you are listening the class like that, I thought. So remaining students also I am telling. So you can ask the questions, See, I will tell one thing. Denser to rarer. Shivani. Sir, what happens when it moves from denser to rarer? Shivani, very good. See, ask questions. If you ask questions, based on that one, I can teach more content. Okay. So otherwise, normally I'll go to the normal content, normal flow with the flow, because so the chapter will take nearly 1.5 hours, 2 hours. So according to my point of view, 1.5 hours, 2 hours also will take, because that much content it is there. Okay, formulas, concept. Okay, fine. So when it is moving, Shivani, listen here. Shivani, if light ray is moving from rarer to denser, so I am taking this the normal line. So it bent towards a normal line. Normally, refraction. What is a general refraction? Generally, we will discuss. Whenever refraction definition we want to discuss, see, generally the light ray moving from rarer to denser. Rarer is nothing but air I am taking. Denser is nothing but water I am considering. Water. So it bent towards a normal line. So in the same case, if the light ray is moving from denser to rarer, it moves away from the normal line. Sir, what is the reason why it is moving away from it? So here you said it is bending, here you said it is moving away. What is the reason behind of it? Because here speed is decreasing. Best example, so road is empty. So like best example, road is empty. So you are going in a school bus or in college bus. So you're going, a driver will take little bit speed. So when suddenly traffic comes, what he has to do? So he has to stop and go, because traffic is there, many vehicles will be there. So we have to go along with the flow. So here also same thing. Here particles will be there. So at a certain distance, so space will be there. Here, so the particles are assigned. The particles are accumulated, the particles are okay, so aligned very in a tight position, means so very close to each other, very close to each other. That's why, so here the speed will decreases, then that automatically lighter will bend towards the normal line here. But whenever it is moving from, so suddenly traffic is cleared, again you are going on the road, then how will go? You will increase the speed. Same thing here also. So best example, you are coming from home to school. From home, so you'll be, your velocity is more, so very happy, very enthusiastic. So when you come to school, so exhausted, energy will be lost. So when you're going to again to home, so you'll get automatically energy. Yes, no, automatically you'll get energy. So like that here also, if the lighter is moving from denser to rarer, it moves away from the normal line because speed is increasing. If the lighter is moving from rarer to denser, it bends towards the normal line, speed is decreasing. Oh, thank you so much. Any other doubts? Any other doubts? No doubts, right? So shall I go on to the next topic? Actually, so as I said, related to refractive index, there are many formulas, many problems also there. I will explain one more concept. After completion of one more concept, then I'll go to the next problems. Problems we have to do, few more problems. This is my handwritten notes. This is my handwritten notes. Those who want these notes, okay, so clearly formulated concept and problems, so with color pens like red, blue, like that, with different pens I used and wrote. So actually this question is very important, expected question. So this question, you can see this one. Okay, so this type of questions are there, so assigned. Okay, so you can see this type of question. So what is the value of this one? What is the value of this one, this question? Okay, very very important question, so you can check. That is the value 1. MCQ's point of view, this question is very important. MCQ's point of view. So I have written all these questions. So those who want notes, you can contact to that number. So I'll share that notes. Okay. So I'll tell one thing. So it's not about the cost. See, if you get what you'll think, normally you'll get. So you won't concentrate much. So if you're spending little much, not too much, little much, so somewhere it will be there. Yes, I'm spending something on it. So it will be very valuable thing. So I have to concentrate. So see, this is my hard work. So if I give freely, then what you'll think? So it's normal only, general only you'll think. So you won't concentrate much. That's why it's very less cost. That's enough, nothing else. No reason at all. So I can share the content. Okay, class is also available for CBSE grade 10 physics. So those who want take, so you can contact to that number for further details. So those who want notes also, you can contact to that number. So you'll be getting. See, I have written nearly 8 books with handwritten notes only. So I did 8 handwritten notes. So here 4 chapters notes, 4 chapters: light, reflection, diffraction, human and color fluid, electricity, magnetic effects of electric current, and 100 definitions. Very important definitions, 100 definitions from 4 chapters, and 100 problems from electricity chapter. So those chapters only I'm explaining continuously in the 9 p.m. Again you will be having 9 p.m. So live class. That time I'll be explaining electricity chapter. Continuously we are working on it. So few students, they asked in the last time class also. So I explained many times electricity, but problems are left. So we are working on problems. So 9 p.m. live class is there. Again, you can join to the live class, listen to the class. So if you feel it, if you want the content again, so you can so contact to that number. So you'll get the details, everything. So for the classes, for the notebooks, everything, right? Okay, done. So come to the next one, next topic. So is there anything else, or shall I go to the next topic? Actually, these 3 questions, as I said, these 3 questions So very important, highly important questions. Highly important question for 3 marks. Highly important question, 3 marks question. Coin is placed, pencil is placed, lemon. So I'm taking, I'll explain. So this is the beaker I'm taking. This is the beaker. Okay. So here I'm considering like this. So here if you are taking, I'm placing the coin here. So this is the coin. So this is the coin. This is the coin. This is the coin. And here, so I'm standing here. I'm standing here. I'm standing here. So this is the coin. I'm standing here. Okay. So initially I can't able to see. So leave it about water. First we should not pour water. So first initially empty beaker. So take a coin here. Empty beaker. So person take the coin. So in this position, he can't able to see the coin. He can't able to see the coin. So after pouring water, what happens? After pouring water, after pouring water, so then the position of the coin rises up. The position of the coin rises up. So the position will be here. So actually this is the coin position. It is at the bottom of the beaker. So it appears here. So the distance between here to here is the distance between actual position. This is actual position of the coin and this apparent position of the coin. So this distance is called vertical shift. This distance is called vertical shift. The distance between actual position to apparent position of the coin. The distance between actual position to apparent position of the coin is called vertical shift. The distance between actual position to apparent position of the coin is called vertical shift. Okay. So this is about coin place. This is about coin place. Where about what about pencil? If you place the pencil, I'm taking the pen. Directly you can place the pencil. So here the concern is when you are taking the pencil, up to here, so up to here until the water level, so it will be normal only. Whereas the water you can see it appears to be bent. Okay, so here actual this is the actual position, but here it appears to be bent. Even if you observe jug is placed in the water, so it appears less depth. Even glass, any object, if you placed in the water, it appears less depth. Okay, less small size that object. Why? Because of refraction. So actually here is the position. This is the actual position. So at this point, the light ray will this object will appears to be bent. Actually, it is not. It's not bending, but appears to be bent. Okay. So that is because of refraction. Okay. And coming to the lemon, next last one is lemon. If you place in the beaker, so here this one we can observe in every shop. You can see every shop, in front of every shop. So if you place the lemon, actually inside of the glass beaker, the lemon is very small lemon only, but when you place in the water, it appears to be bigger. So because of refraction only. So do you have any doubts? So if you don't have any doubts, so I'll continue the next topic. So if not, I will explain. Do you have any doubt, children? Students? At least if you say yes or no, so then I'll go to the next one. Okay, fine. So no, sir, continue. Thank you for confirming. So that is about coin and pencil. So 9 o'clock again class will be there. So 8 o'clock I'll give break. So 1 hour you can have dinner, and so I'm not saying, sir, only you have to eat in that time only. So I'm not saying like that. So just I'm conducting class at 9 p.m. So you can take lunch early and join to the class for learning the subject. Okay. So coming to the next one. Yes. This is a very important, crucial topic. That is, sir, you are saying every time very important, highly important. Which one I have to leave? Which one I have to study? generally we are writing board exam. Right? So if you are writing board exam, you have to learn everything, right? You have to learn everything, right? So at the end, I will tell. At the end, after completion of complete chapter, I will tell highly important questions, highly expected questions, highly important questions. I will tell. So, but explanation of sub concept you must explain, right? So because every time when if I say this concept is not important, you leave like that. But in the exam hall, if this concept comes, what you will tell? Sir said this concept is not important. I left like that, but that concept only came in the exam. What I have to do? I okay. So we can't that situation we can't do anything. So what we have to do? So we have to prepare. But all concepts, all topics we have to prepare, but few topics we need to concentrate little more. That those topics I'll tell at the end of the class. So here you can see I'm taking the normal line. So here generally this is a rarer medium and this is a denser medium. Rarer medium, denser medium. If the light ray is moving from denser medium to rarer medium, generally what happens, it moves away from the normal line. Generally what happens, it moves away from the normal line, right? If the light ray is moving from denser to rarer, it moves away from the normal line. Now you can take here, I'm considering the same one. So very important, listen carefully, focus carefully. So very important definition it is. So if the light ray is passing like this, if the light ray is passing like this, if the light ray is passing like this, so light ray is moving from denser to rarer, denser to rarer, denser to rarer. So light ray is moving from denser to rarer, denser to rarer, denser to rarer. Video is not passed, I am repeating. Okay. So denser to rarer. So at certain angle of incidence, the refracted ray passes along the surface. The refracted ray passes along the surface, gauges along the surface, moves along the surface, or makes 90 degrees with the normal line. Makes 90 degrees with the normal line. Refracted ray makes 90 degrees with the normal line. Makes 90 degrees with the normal line. At certain angle of incidence, the refracted ray makes 90 degrees with the normal line. That angle is called critical angle. So what is the critical angle? At certain angle, so the refracted ray passes or gauges in the sense, so moves along the interference. So that angle is called this, because of this angle only, right? So which are the positions, which are the higher heights you reach, so the basic foundation is very important here. So same thing, so because of this angle, the light ray passes along the surface, or gazes along the surface. So this angle is called critical angle. Okay, so once again, so those who want to listen this topic, just listen once again. At certain angle, so at certain angle of incidence, generally what happens, I'll tell what exactly is happening. So I'm taking here, so one light I'm taking, it moves away from it. Again I'm taking, move away from it. Move again, so moves very close to the interference again. So at certain angle, if you see, it passes along the surface. If you keep on sending the incident ray at a certain angle of incidence, the refracted ray passes along the surface, gauges along the surface, moves along the surface. That angle is called critical angle. That angle is called critical angle. So at certain angle of incidence, the refracted ray makes 90 degrees with the normal line or passes along the surface. That angle is called critical angle. Clear? So this is very important. Next one, I'm going to the total internal reflection. These two are very sensitive definitions. So if you leave with normal line, so maybe in exam hall they will get. So if the light ray is passing, sir, why you are taking only here? We can take any other point. Yes, we can take, but So if the light ray is coming, so you are taking the source here. That's why I'm taking the light ray here. So at certain angle, so it makes more than 90 degrees. So here 90 degrees, it's more than 90 degrees. If the light ray is passing, refracted ray makes more than 90 degrees. So in the rarer medium, this is a rarer medium, right? Then reflected is. So then light ray reflect into the same medium. Reflect into the same medium. Reflect into the same medium. So here the total light internally reflection takes place. Total light internally reflection takes place. Total light internally reflection takes place. That is called total internal reflection. Total internal reflection. So example for total internal reflection, optical fibers. Optical fibers to send the signal without much losses, without loss. So we are using the optical, this phenomena in optical fibers. Optical fibers. Clear? Any doubts? This is a critical angle, total internal reflection, refraction. At least you can say you can say yes, no doubts. So go on to the next topic. Click on the like button. It's so general things, right? So in the class, if I ask, so do you have any doubts? So we'll say no. At least so we will note the head like this. No sir, no doubts. But here I can't understand, right? So like that, at least no sir, you can go like that. So if you tell, I'll feel very happy. Thank you so much, Shivani. So only one student is responding. What about remaining students? So remaining students also need to respond. Okay, shall we do problems? Shall we do problems? Actually, until here it is completed. So this is the concept complete. Only this is small part only. This is small part only. So entire here, all the notebooks. So here for refraction, three definitions. For refraction, three definition. Once you observe. For refraction of light, there are three definitions. I wrote three definitions. Three definitions. Refraction of light. You can see this is my handwriting only. Okay, you can check the handwriting and you can check on the board also. So with so much hard work, I wrote these three definitions. I'll read out. Refraction of light. When light is traveling obliquely from one medium to another medium, the direction of propagation of light in the second medium changes. One definition. Second one, the phenomena of bending of light at the surface separating two media is called refraction of light. This is due to change in speed of light from one medium to another. Third definition, the process of changing speed at an interface when light travels from one medium to another, resulting in a change in direction, is called refraction of light. So three definitions are not same. So three definitions are different. Three definitions are different. Clear? Okay, done. So now I am going to the problems. So those who are interested, those who are ready to do the problems, so please do like and share and subscribe my channel for further notification, further updates, further. See, there are videos related to physics. So if you click on like button, if you click on bell icon, so you'll get the notifications. This is common only, but I have to tell, right? So it's a common thing, general thing. So I need to address. That's enough. Light enters from air into glass. Light enters from air into glass having refractive index. So what is speed of light in glass? The speed of light in vacuum is. So here the question is light enters. So this is the light. Light is entering from air. This is the air. I'm taking this the glass. Okay, glass. Light enters from air into glass having refractive index. So n equal to 1.5. 1.50. Anyway, 0 is no use. You can take 1.5. If the 0 is here in front of 5, there is a value. But so we have to consider. But if it is there, no need to consider that one. You can write directly 1.5. So what is the speed of light in glass? Those speed of light in glass. So we have to find out speed of light in glass. What is speed of light in glass? The speed of light in vacuum is, that is nothing but speed of light in air. I am taking speed of light in air. That is nothing but 3 into 10 power 8. 3 into 10 power 8 meter per second. Okay, so this is the question. How to solve it? Yes, sir. No, no. Okay. So how to solve it? Anyone can try. See, if you try, you won't lose anything. If you did not try, you lose something. Correct, no? If you try something, there is something, there is a possible way you'll get it. If you did not try, so nothing you'll get. You'll get fear. Something is dangerous. So something is there. I can't able to do it. Like that, the fear will generate more and more. Then even after some time also you can't able to try. If you don't mind, I will tell one small like story. Is if it is okay, because concept is in middle, so please adjust. I'll tell a small story. It's a very important story also. So there is a frog. There is one frog. So initially it will be in one bowl. Okay. So what the frog will think? So it is very happy. So in this place is very happy. So very sufficient water is there in the bowl. In the bowl, sufficient water is there. Happily I can swim. Happily I can drink. Happily I can live. But actually the frog is there in the heating bowl. Means the person brought that frog and kept in the bowl to heat. Okay, so what happens, slowly the person is heating the bowl. So the frog thinks, okay, very happy. So it's a normal heat only. So we no need to worry about it. So I can stay like that. So it is adjusted. The frog is adjusted. So when it is start, water is getting boiled before. Slowly the temperature is rising. That time the frog jumps out of the bowl, out of the comfort zone. So you have to understand clearly. Out of the comfort zone. Out of the comfort zone. So there is chance to live. But slowly the person is heating the water. Slowly heating the water. So the temperature of the water is slowly rising up. Slowly rising up. So at certain time, completely each and every time when temperature is rising up, the frog is adjusting with the temperature, adjusting with the environment, adjusting with the temperature, adjusting with the environment. So the frog can't able to come out because of the environment is adjustable. The environment is comfort. Environment is comfortable to the frog. Then what happens after started boiling, then frog is no more. Here from this story we can understand the moral of the story is, so we have to move out from the comfort zone. We have to move out from the comfort zone. We have to understand when to move out. Yes, surely we will adjust with the comfort zone, definitely one or some other time, but we must come out. We must come out from the comfort zone. Then only get success. Okay. So whether you are studying, studying, writing, practicing, still you are not getting result. No problem. If it is possible, run. If it is not possible, walk. Still it is not possible, travel. But don't stay in the same place. Okay. So only body is there. So for drinking, no use of salt water, but still it is moving. So what about us? So surely we have to try. Once again, the quotation actually it is there in Telugu. So that is a famous quotation. So if it is possible, you can run. If not, walk. If not, travel. Okay, travel. So but don't stay in the same place wherever you are there. Okay, try to walk, try to move. Surely you'll get one day result. Okay, come to the point. So now I'm going to the next one. So here, see, I'm considering the refractive index. Refractive index is there, velocity of the glass is there, and velocity of the glass we have to find out. Velocity of light in air or vacuum is given. So what is the formula we can use? What is the formula we can use? So normally n equal to c by v. This is the only formula. So we have to find out velocity of the glass. We have to find out velocity of the glass. So v equal to c by n. That is nothing but 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. This is by refractive index is 1.5. So what is the velocity of the glass? Anyone? I hope 2 into 10 power 8, right? 2 into 10 power 8 meter per second. Any doubt? No doubt. Okay. Shall I go to the next one? Shall I go to the next one? Yes. Then see, speed of light is there. So second question. So do you understand? Yes, very good. Thank you. Second one I'm taking. So speed of light is there. Speed of light in air I'm considering a vacuum. So that is speed of light in vacuum or air. So 3 into 10 power 8 meter per second. 3 into 10 power 8 meter per second. And what will be the speed in diamond? Speed of light in diamond. So diamond I'm considering VD. Speed of light in diamond. And refractive index, same formula. We can use same formula. So the values are different. Same formula. Will you try and tell the answer? So anybody? Will you try and tell the answer? So refractive index n equal to c by v formula. So I'm giving the clue. I'm giving the hint. So you can try to solve and tell the answer. Okay. So 10 power 8 I will tell. So at least fill the gap. So v I want to find out. So here into 10 power 8. Maybe 10 power 8 typing is difficult. But I hope this value we can type it, right? Here. Fill the gap. Anybody? So 10 more minutes I'll take the class. Next we'll go to the electricity problems. So come and join to the 9 o'clock 9 o'clock live class. It's very interesting class. So problems will come. We'll do problems, all the problems. So because electricity problems we have to do more. That's why I'm telling. So join to the live class. Join to the live class at 9 p.m. Okay. So you can today only. Every day 9 p.m. Every day 9 p.m. So whatever I am taking, remaining topics I am discussing. Other than 9 o'clock, remaining topics I am discussing. So remaining those who are there in the live class, those who are went. So please try to join to the live class at 9 p.m. Definitely we'll discuss electricity chapter. Okay, this is the last problem. So we'll conclude that. If I go to the next one, it may take time. Okay, so I'm giving time to you to solve this problem. Do you have any doubts? So if you have any doubts, you can let me know. Otherwise, we'll go to the 9 p.m. class. Join to the 9 o'clock today. So have dinner and come and join. So learn more concepts, practice more concepts. If you have any doubts, you can try to ask doubts. So my point is ask more doubts. Then we can get the concept. Okay, na? So thank you so much. This is your Shiva sir signing off. Thank you so much for joining. See, answer is 1.2 something. 1.2, right? Answer to this question is 1.2. 1.2 is the answer. 1.2 into 10 power 8 meter per second. Yes. Very good, Shivani. So here man of the match. So every time if we completed match, So they'll give man of the match. So now today I'm giving to you. So for attending and working, so doing problems along with me. So you are the man of the match for this class, Swani. Congratulations. So join to the 9 p.m. class. So we'll see. Thank you.